Hello, in this video we're going to be talking about the second alternative to multiplication in the complex field, and why this definition also fails to be a field. So we're going to take the standard multiplication that we know works for the field, but we're going to replace that minus sign in the real component with a plus sign, as denoted in gold. So the best way and the easiest way to do this is to check if C without the 0 element with multiplication is an abelian group. So we're just going to kind of piggyback off of what we did in the previous video with the first failure of multiplication, and we're going to just look to see if it fails at the inverse step. So in order to first check to see if there's an inverse, we have to define what the identity element is. So we claim that the identity element is the same as the identity element when we defined complexes and proved it was a field, 1 plus 0i. So we're just going to multiply it on the left and right by a plus bi and confirm that this is in fact our multiplicative identity. Now that we've shown that 1 plus 0i is the identity, let's go ahead and find an inverse for any arbitrary element a plus bi. So we want a c plus di such that when we multiply it, we get 1 plus 0i. And we're just going to multiply it out, set it equal to 1 plus 0i, and set the real and imaginary components equal to each other. From this, we're going to get a system of equations, and from that system of equations, we'll solve for c and d in terms of a and b, and see if it works. Now that we've come to a conclusion of what c and d are, let's go ahead and multiply it by a plus bi. Let's just do it on the right now to just kind of get a feel to see if it works. And then we'll ask ourselves, are there any problems with this? And as we see, this is great. We get 1 plus 0i. But there's a small problem. What if I have the real and imaginary component equal to each other? So for instance, I have 1 plus I. Then our denominator is going to be 1 minus 1, or 0. And since we can't divide by 0, we don't have a valid complex number in these cases. And since we don't have a valid complex number for the inverse of a non-zero element, we have to conclude that this fails to be a field with the multiplication as defined. Thank you for watching.